I'm John Price. I'm a retired physician, and I got interested in the climate problem a while ago, and then I realized that this was going to be a very big issue for my young grandkids. They're way too young to know anything about it now, but the way it looks, if we don't do something pretty soon, then they'll wake up to the problem and find that we left it too late. So that was what made me decide to try to do something about it. I'll just introduce you to a few of them now. Here they are down at the beach last summer. Now if you're a grandparent, you'll know just what it's like to look at them and wonder about the future. What will it be like when they're our age and maybe thinking the same things about their own grandkids? And there's something very, very ugly about the idea that they might have to wear the consequences of something that we should have prevented. In 1945, after the atomic explosions in Japan, scientists began to realize that their discovery had brought vast implications for future generations. Sometimes they saw knowledge brings responsibility. Well, it's like that now. Scientists have been trying to tell us for years that a huge ecological problem is on the way. And it would be visited on these little kids, people of the future. And if we're to avert it, we have to do it now. Now, you'd be entitled to ask, well, can we really have clear and certain knowledge about the future? Isn't it all guesswork? Well, the answer is yes, we can. And no, it isn't guesswork at all. I want to show you 3 present trends, very, very carefully observed and measured, that point like signposts to the future. Here's the first one now. This graph shows what's happened to the human population over 8,000 years. Obviously, something happened about 3,000–4,000 years back. That was when we learned how to establish empires and live in bigger and bigger cities. That sort of upward trend that you saw turned into something quite different about 250 years ago. 1800, we reached 1 billion. And then every billion that's come since has come faster and faster and faster. When grandfather came to Australia in 1910, there were 1.6 billion people in the world. A century later, when my second grandson came, it was 6.5. Now, just imagine you had a farm and I was studying the population of rabbits on the farm and I showed you this graph. You'd know right away there was a problem. And the name of the problem is a plague. Everything eats, and food supply is one of the things that limits population, so this can't go on forever. Of course, humans have a great many more needs than rabbits, and our impact on our environment is correspondingly greater. But just like rabbits, we can gobble up the resources that really belong to our descendants. Now by 2050, the experts tell us there should be around 9 billion people on Earth. That's an increase of 50% over what we have now. And most experts are very concerned about this. It would be different, they say, if all along we've been taking account of what we used up and what we could replace, but we haven't been. That's apparently not something that humans have ever done in history before. This is a very complicated subject. The problem has many consequences, but I just want to show you one of them now. This is the island of Borneo. It's the 3rd biggest island in the world. 50 years ago, as you can see, it was covered in a tropical forest. Today, there's not much of that left, and what is left will probably only last a few more years. Now, it's no coincidence that that happened in the same 50 years that the human population doubled. Adding 3 billion people, large mammals, to an ecological system is a pretty big deal. That's what it used to look like in Borneo, and that's what it looks like now, at least a lot of it. That's a giant palm oil plantation. All the world's tropical forests are being treated much the same way. That's what's left of them, About 100,000 acres of tropical forest disappears every day. Some of it logged, but an awful lot of it just goes up in smoke. Bad news exactly like this could be given about many other problems with human impacts. The depletion of fish in the ocean, for example, the loss of topsoil on cultivated lands, the expansion of deserts, the shortages of fresh water, and many more. These are all stories about the loss of resources that rightly belong to our descendants. Just take a look now at the bottom right corner of this again. Whatever happened there is the key to our story, and I'm going to come back to it soon, but for now, take a look at another well-measured trend. This chart shows the mean temperature of the Earth's surface for 160 years. Why 160 years? Well, that's about as long as there have been enough weather stations around to make these measurements. The three colours belong to the world's three main global temperature monitoring centres: the Goddard Institute in New York, National Climate Data Centre in Colorado, and the Hadley Centre in the UK. You can see that they pretty much agree. The thing is that from here to here, in 1 century, the mean temperature of the world has gone up 0.8 degrees. Now, I tell you now that that's a pretty big rise. It's fast and it's large. This is another way to show the same thing. Here the individual years are ranked, with the hottest ones on the left and the coldest on the right. The latest 50 are there in the middle, so you can see them clearly. There are 19 following 1990, and of those, 15 of them occupy all of the top 15 places. The others are 19, 21, 23 and 30. Of all the years since 1970, all but 2 of them are in the top 30 places. Here's the 20th century warming in a longer context. Temperatures before 1850 have to be recovered by scientists from various clues buried under the sea and ice in all sorts of places. Now, although these techniques aren't as accurate as thermometers, there are quite enough of them to establish a trend. You can see the trend there. 20th century warming is severe, sudden, and unique. Where does all the heat go? We know it doesn't stay in the atmosphere. That gets hot and cold all the time. No, the heat is in the ocean. The ocean is by far the biggest heat reservoir on Earth, and people have been measuring the ocean heat content for some years now, and there it is. Another steadily rising trend. Now, I want to say something more about the climate history of Earth later on. But for now, just take a look at this. Another trend unique to our time. This is a measurement record made at an observatory on the side of a mountain on Hawaii, specially built for the purpose. The man who put it there is Charles Keeling. What he wanted to do was to pin down exactly as he could what was happening to the CO2 in the air. And it's thanks to him and his successors that we know beyond a shadow of a doubt that this gas has been accumulating in the atmosphere at least since he started measuring in 1958, and that when it began, its concentration was 315 parts per million, and now it's 390. Look carefully at the graph again. That sawtooth pattern is something Keeling discovered, and within a couple of years he'd figured out the reason. The great northern forests of the world draw down carbon dioxide during the summer when they're growing and release it again in the winter. And after a few years he found that the mean had risen about 0.7 parts per million, and it kept doing that year after year. But look again at the red trend line in the middle. It's not a kind of rough straight line, it's actually a curve. And the increment that Keeling measured back then has tripled. It's now a bit more than 2 parts per million and rising. CO2's measured in many places in the world now. Here are 4 of them, way up in the high Arctic in Alaska, Hawaii, Samoa in the middle of the Pacific, and the South Pole. You can see that the 2 southern hemisphere ones don't have much of that sawtooth pattern, but they share the rising trend just the same.